Okay, so welcome to Pick 10B. This is with instructor Steven DeSalvo, that's me. I like to start, how many have taken a Pick course with me before? Okay, so most of you have not. Okay, so the one thing that I do that every class, I start off the class by like clicking on the microphone and then saying, good afternoon. And then I like to hear a nice hearty, good afternoon in response. If you wouldn't mind indulging me on this, just this one thing, okay? So let's try that again. Let's click. Good afternoon.
Good afternoon.
Okay, so welcome to Pick 10B. As you can see, we are audio recording this and video recording this. What this means is any question that you ask will be publicly available on the web for anybody to come and look at later on, okay? What it also means, however, is that all of the lecture material is freely available on the web, which means if you miss a lecture or anything like that and you want to go back and review the lecture material, the actual lecture that I gave, this is freely, publicly available. Okay? You don't have to be a UCLA student. This is just public, a public link. Okay? So just a warning, you are on camera. Okay? So the reason I do this is because let's see. Hang on. Attendance. Okay. Attendance is not mandatory. Show up if you want. Don't show up. It doesn't bother me. I don't take offense. I probably won't even be able to connect your name with your face anyway. So, okay, don't be embarrassed by it. Just if you benefit from physically being here, please, by all means, attend. If you do not, like for me personally, I dislike attending lectures in the flesh. I prefer to, sit at home in front of my computer and just watch it and pause it whenever I want and things like that. Okay, so I will be here. I will give the lecture at this, time Monday, Wednesday, Friday. I don't expect you to be here. I'm not demanding that you physically be present. All I'm saying is you're responsible for the material covered in lecture, and that's what I'm providing for you pretty much whenever you want to have access to it. Okay, so it's posted on the web. You can access it whenever you want. Basically, the only trade-off is, not the only trade-off, but you wouldn't be able to do this anyway. Just, obviously don't send me an email with a question like, hey, professor, what did we cover? Okay, I'm going to just ignore that. Okay, so that's the most important thing, which is that attend or don't attend, it's up to you. Okay, just learn the content and be aware of the content. Okay, the second thing is about these lecture slides. I posted all of them for the entire quarter, but I'm not going to use them for every lecture. Okay? They form the core of the content for the course, but some of the style conventions are outdated. So what I would encourage you all to do is read the lecture slides before you come to class. And then during class, I'm going to go over the same topics, the same ideas, but the way in which I go over them or the particular style that I'm going to be championing is going to be different than what's on the lecture slides. This is particularly true for operator overloading, which is going to be our first topic. Even though it's chapter 14, we're going to start with certain topics in operator overloading. Okay? So, that being said, it's not just about reading the lecture slides or reading the book. You have to at least look at the code that I write during class and that I will post absolutely on CCLE. Okay? Because that code will contain the style conventions that I'm going to be demanding for this course. Anybody can write a function that performs a certain operation, but I'm not going to be asking you to do that this quarter. I'm going to be telling you, all right, there are certain style choices you can make which will make your code more readable and more easily extendable, and we are going to adopt those conventions not out of necessity, but out of an intense desire to make sure that the code we write does not just get completely rewritten the next time we have to modify any part of it. This is what has happened to me time and time again, which is I write I spend like a week or so, I write this really complicated, really intense code, and then if I want to do anything more with it, if I don't follow these certain conventions, I essentially have to start over. And there's a time and a place to start over, but then there's a time and a place to say, well, wait a minute. Okay, isn't there a better way? I will show you at least a better way than to just kind of go randomly and code up what you need when you need it. Okay? So again, the emphasis is going to be on style choices. Not just about doing whatever it takes to get it done, but about making sure the code you write is clean, professional, and easily readable and easily extended. Okay? That's the idea. I don't want to go through all of these, but in this first lecture one, I want to actually start coding today. I want to start showing you some of the style conventions today, and that will lead you into your first homework assignment, which is due on Friday, and it is about coding up a class that mimics a polynomial. And again, don't freak out. This is not a math course. This is not a CS course. Okay? But a polynomial is this kind of more abstract structure that you've all worked with at some point or another in your elementary education. Okay? And all I want to have you guys do is, using your intuition about the logic there, just codify it in code and use that as a way to demonstrate proper ways of commenting code, structuring code, etc. Okay? So with the polynomial class, there's really only two functions which are going to be kind of annoying to write up. One is the multiplication function, and one is the addition function. But go to the discussion sections, ask the TA to go over the algorithm with you, etc., and you should be fine. All the other functions, all the other part of the homework assignment is really mostly about just calling those two functions. Okay? And that's what I want to emphasize. This is really only a few really detailed parts of this assignment, and the rest is just logic. Just basic, elementary, logical reasoning codified in the programming language. Okay? So don't be intimidated, but take this assignment seriously because it is going to form the basis of the first 3 homework assignments. Okay? Okay. Then usually the first question I get asked is, hey, professor, the class is full, which it is, and the wait list is probably full as well. I will let all waitlisted students into the course. If the enrollment dips below, I think, 60, right now I think it's at 66, including the wait list. If the enrollment drops below 60, I am open to adding more students to the course. But if it does not drop below 60, then I don't have any PTE numbers to give. So you can't go through me. You can go through MS 6356 and talk to them. But as far as I'm concerned, the cap is supposed to be at 60, and I have the option of letting in all the waitlisted students. I exercise that right. If you're on the wait list, you're safe. You'll be in the course. But if you're not on the wait list, you have to get on the wait list. And if you don't, then there's a fairly small chance it's just not going to work this quarter. Okay? And in particular, most of the questions involving logistics of courses and degree programs, I honestly don't know. Okay, so just check in with that office there, and they'll be more helpful than I will. Yeah, that's just a reiteration. Go to MS 6356. Here's the grading scheme. If you took Pick 10A with me, I think this slide is exactly the same. So the grading scheme is pretty open. I try to write the exams in a way that I don't have to curve, but if, for example, I write a hard exam and I look at it and I say to myself, gee, that is kind of a hard exam. That is definitely too high of a standard than what I've done in previous quarters or what I would expect from this course. Then I will maybe exercise the right to maybe say bump up someone who's got an 88 or above, or you know what I mean? So if you get a 90 or above, that's pretty good indication that you're going to get an A. That can be a hard cutoff, but I might lower it if I make the exam too hard, if I deem that the test of knowledge was not adequate or was not what I would like it to have been, I might lower the bar a little bit. Okay? But otherwise, just assume it's, you got to get around 90% of the information. Otherwise, you're starting to get a little bit in danger of going into the lower ranges. And then I anticipate most students are going to get the A-B range, and then depending on the size of the class, there's the C range as well. But I will give out as many A's, B's, etc. as are earned. So it's not like a curve in the strict sense. It's more of a curve in the sense of if I feel like the level that I'm demanding of you is exceeding what I've demanded in other students in the past, then I might lower the bar a little bit more. Okay? But if you all succeed, if you all get 90 plus on everything, there's nothing stopping me from giving all of you A's, except for statistics. So it's not going to happen. What I mean is it's not going to happen, statistically speaking, in any population of this size. You're going to have the variation. Okay? But there's no law saying I can't do it. Okay? So if you want to break all the statistical laws known to man, you absolutely can do so. Okay? It is possible, but highly unlikely. Okay? So it's up to you. Spend as much time or not as you like on the course, but then that's the grading scheme. Okay? So all things being equal, if you get 90% of the course material correct, then you should expect to get an A. Okay? Oh, there's one other thing too. If you haven't taken a course with me before, I like to do this thing where I'll drop the lowest midterm and throw all of that weight into the final. And the reason I do this is because as long as you learn the material by the end of the course, I can forgive you. Okay? So it's not about, I really want to emphasize, yeah, you must take at least one midterm. If you don't take either of the midterms, then that you're not going to pass. Okay? But as long as you take at least one midterm, if you take both midterms, then I'll just calculate your grade in 3 ways. Okay? I drop the first midterm, calculate it, drop the second midterm, calculate it, don't drop any, calculate it. I take the largest of those 3, so it's win-win for you guys. Okay? So just be aware, even if you take one of the midterms and you think, oh no, I really bombed that one, not all is lost. You can still make up for it by just making sure on, for example, the final exam that you are proficient by that time. Okay? So that helps to alleviate some of the pressure of saying, okay, as long as you eventually learn the material, there is some wiggle room. Okay? So that's something that maybe is not in a lot of your courses, is drop the lowest midterm. Okay? So let's see. Office hours are not TBA. This is an old set of lecture slides. 10 to 11 a.m. Monday, Wednesday, Friday in MS 6191. 10 to 11 a.m. So I teach a course, I teach a 10C module right before this, and the office hours are right before that. Okay, so 10 to 11 a.m. Monday, Wednesday, Friday. And that's a hard cutoff too, because I teach at 11, so it's more like 10 to 10:50. Okay. These are things that in these next few slides you should just read them on your own. Okay, I don't want to reiterate them because they're posted on CCLE. Download this lecture 1 and all the lecture notes, and then just kind of keep background reading it. And in addition to, this is the textbook, the same one I believe as we use in 10A. So I'm going to take problems from the exam based on this textbook. The course material roughly follows this, more or less in the order in which it's presented in the book. I'm going to start with chapter 14 material first, and then go from chapter 8 sort of onward. Okay? Let's see. Email etiquette is another important thing I just want to get out of the way. This is the most important part of the slide. Okay. Do not expect a response from me, period. All right? You can email me whatever you want. Feel free to email me whatever you want. I will probably even read it. Okay? But most of the emails I receive, I don't find it appropriate to give a response via email. Okay? So you may absolutely, for example, at the end of class, come up and say, and ask me the exact same question you wrote in the email that you didn't get a response to. That's fine, as long as it's a very quick question and I can answer it right away. But just because I receive an email with a question, I don't always think it's appropriate for me to respond in email. Sometimes I might bring the question in front of the class and answer it to the entire class. Sometimes I just don't think it's worth the time to give an answer to it. So don't take offense to it. Just, you can email me whatever you want, but just don't be offended if I don't respond. Okay? So, and in particular, if you come to office hours, you can absolutely ask me whatever question you want. It doesn't matter what it is. If you come to office hours and you ask me like, hey, I don't understand what int and double are, that's fine. Ask now rather than later on. Okay? So at office hours, you may ask me whatever you want, but email, you may never hear back from me. Okay? So you might. If you ask a very specific question, which I think is absolutely relevant and important, and I can really quickly do it, I may actually give you a response. But otherwise, I probably just won't respond. And it's nothing personal. It's don't be embarrassed or think, oh my God, I asked a stupid question. He's going to think I'm an idiot. It's none of that. It's more just, okay, there may even be external reasons why I didn't answer it. Okay? Feel free to ask after class, during office hours. Okay? So don't assume the reason I didn't answer is because it's not a good question. Okay? So I just want to kind of leave that out there. Students find me usually very approachable, so please don't hesitate. If you do have a question, especially if it's a review question or a Pick 10A question, let me know sooner rather than later. Okay? If you're going to email me code, it's not a successful strategy to email more than 3 lines of code. It's not probably going to just get ignored. Okay, there's a syllabus. Again, this thing is wrong. Your first assignment is due on Friday at 5 p.m. Your homework will be due on Fridays at 5 p.m. This is going to be a weekly occurrence. That should be fixated in your mind that Fridays at 5 p.m. you will be turning in something. The first 4 assignments are already posted. Okay? So the only thing holding you back right now is understanding what the assignment is asking you to do. And that's what we're going to be covering in the next several weeks. The first 3 assignments are about what are called operator overloading, which is the subject of chapter 14, and that is exactly what we're going to be starting our material with. So let's see. Outline of topics is roughly chapters 8 through 14. I might throw in some stuff from chapters 15 and 16 as well. In particular, I'm going to nix this part right here, okay? So this stuff on how ints and doubles are actually stored in the computer, students have told me this is the one thing they remember from my courses and they hated it. And to be fair, it's not very useful anymore for any of the stuff that I would conceivably do. So it's a really cool topic, but it's a little too detail-oriented, I think, for a programming computing style course, okay? So I'm going to nix this. There's a week of lecture slides on how numbers are stored in binary in the computer. We're not going to cover that. Instead, we'll probably cover chapter 16 or parts of it, which is on templates. And templates are a really cool feature of C++ that I think is worth knowing. Even if you never take 10C, just knowing of their existence is a definite plus. So basically, chapters 8 through 14 is the content of the course from your book. Midterms, final, those are posted on the syllabus. Cheating is not just copy-paste. This is important. The general rule of thumb I have is just don't let anybody look at your code. Okay? You can discuss the idea of the algorithm or how to solve it or what needs to be done, but just as a rule, just don't let anybody look at your code. And I have to tell the anecdotal story. I do this every quarter. Once upon a time, I was in high school, and I took my first C++ class, and there was a really hard problem that we were all trying to solve, each individually, and most of us got it. And there was one student, one of my friends, who just couldn't figure out this one part of it. And this student asked if they could just see how I did it. And I said, yeah, sure, why not? Because this person, that person was just as smart as I was, just as capable. I figured, okay, it's probably harmless to just say, okay, there's just this one part here, and that's how I did it. Well, so rather than just discussing how I did it, I showed this person the code, and I said, okay, so that's what I did here, the code right there, and this person just glanced at it, less than a minute, probably no more than 30 seconds, and said, oh, I get it. Okay, thanks. Goes back, finishes writing up the algorithm, and then the instructor comes along, like a couple minutes later, looks at my code. I was like, so-and-so did exactly that same approach. The code looks almost identical. And I'm like, okay. I don't think the person meant to copy the code, verbatim, but just once you see how something is done, it can be really hard to code up your own solution. It's kind of like when you read a passage in a book and you want to quote it or make a reference to it. It can be really hard to rewrite it in your own words. Okay, so just discuss the ideas if you must, but don't let anybody look at your code, and you're probably fine. Okay. Also, this is also very important too. I do have ways of finding people who copy each other's code. I have ways of finding out if someone copied and pasted parts of the other person's code. I have ways of finding out if somebody copied and pasted code and just changed some few variable names around. I have ways of, okay, you get the point, which is I do check for commonalities in code using a program that is pretty good at detecting those things. Okay, so just want to emphasize, don't think you can just copy and paste and then change a few variable names around. Just don't do it. Okay? If you can't do the assignment, come get help, or just don't turn it in. Okay? Also, I am a probabilist, so I understand the law of rare events and how these coincidences work. So I know how to interpret oh, hey, we just so happened to turn in exactly the same code versus okay, so I understand the intuition behind how these things match up, okay? And the programs that I use take those things into consideration. Okay, so just as a warning to you, yes, I do check. Okay. And if you're registered with OSD, just let me know in advance. You can read the rest of this. Here is something that is kind of important. You see this purple text? Okay. This is incredibly important. I will demonstrate some code to demonstrate just how important this is, okay? Okay. There is a set of rules that are considered valid C++ syntax. You are using Visual Studio 2012 Ultimate to turn in your homework and to test your assignments. The homework check program is not using the same compiler that the Mac uses, or Xcode. Just because your program compiles and runs on Mac does not mean it's going to compile and run in the same way on Visual Studio 2012. You have to check it on Visual Studio 2012 Ultimate, the exact same one that's in the PIC lab. There have been several cases of students turning in perfectly valid code that works on their Mac or on Visual Studio 2013 or on Visual Studio 2012 Enterprise or some I don't know, some different version. Doesn't matter. It has to compile on the exact same edition as what's on the PIC lab computer. From what I know, that's Visual Studio 2012 Ultimate. I thought we would have 2013 by now, but we don't. Okay, if you took my 10A class in the summer, I kind of hinted that we'd have more functionality. We didn't get it. That's fine, though. Okay, it's not going to affect us too much this quarter. But there's one in particular set of syntax you will see on the internet, and you will be tempted to use it, and no, it will not work. And yes, I will show you what that is today, in a bit. Okay, so just as a warning, there is the language C++, and then in 2011, there was a tremendous overhaul of the language. All of the old stuff will still work, but they added a bunch of new stuff. And what I'm trying to point out here is the new stuff is, say, this set here. Visual Studio 2012 only gives you a subset of this functionality. Not everything which is technically valid C++ code will compile in the version we're using. But it's a small subset, small enough subset where it shouldn't be a big deal. Let's see. Begin course material. Okay, so let me not go through these examples. Here's examples of how to do commenting of functions and classes and things like that. You'll get the hang of it, because I'm going to code in front of you, and I'm going to exercise these good style choices, at least decent style choices. And you will see very quickly there's just a few simple rules, and then you just make sure you follow them. Okay? Let me start out, though, by, I've been kind of droning on and on. Anyone want to see a game? Yeah, all right. Now, has anybody ever heard of the game Number Munchers? Yeah, no one's ever heard of this game. I figured out why, too. I think it's because it was made by a company located in St. Paul, Minnesota, and I grew up in Minneapolis. And so I guess my school incorporated the local tech thingy. It's a really fun game, and it's a shame that more students didn't get a chance to play it, because I got addicted to it after a while. I ripped it off, basically. Not ripped it off, but I took the mechanics of the game, I took the logic of the game, and I made my own version, which is written not in C++, but in a related language called Qt, that I teach in Pick 10C. But it's pretty much just C++ syntax with a little bit extra stuff. Okay? So what I want to do is show you, I wrote this in a day, and in a couple hours on a second day. Okay? But let me just show you this game, and yeah. So I'm just using the arrow keys to go around, and if you look up there, it says multiples of 2. So I can hit the space bar, and I can munch these multiples of 2. And I have to avoid the ogres, otherwise I lose a life, supposedly. But if I munch an odd number, which is not a multiple of 2, I lose a life. And then I change the value to 111 just to show that it was a bad munch. See, bad munch. Okay. Oh no, I go back to good munches. Supposedly, when I hit an ogre, it should take away a life as well, but it doesn't. It just does that. Okay. And then also too, when I finally lose all of my lives, it should just stop the game. But it doesn't. Okay. But you get the idea. This only took me a day of coding to code up. Okay. So this is not. I mean, when you're done with 10B and when you go into 10C, you will have almost all of the necessary background to pretty much write a game or something similar. And that's what I'm having the 10C students do. For the first half, I give them the traditional homework assignments, and for the last half, I'm planning to let them create their own project, their own GUI-based project, whether it's a game or something similar. So this is what we're leading up to. All right? So this is kind of a motivating, like, why are we learning this stuff? Well, because you can do cool stuff like that very soon. You can even do cool stuff like this right now, but I defer teaching it until 10C. The only thing you really need to know for this is memory management. You just need to know memory management extremely well, and then everything else just follows basic object-oriented principles. And there's a couple things like an event handler and how time works into this whole thing. But in terms of like what you need to actually code this stuff up, it's really just classes, member functions, and just the basic logic. Okay, so you already have almost all the tools at your disposal. Now we're just going to get you much more comfortable, much more familiar with coding, so that when the time does come and you have access to this, you can actually sit down and in a relatively short time make your own game. Okay. Okay, so let's start coding. Okay, so let's see, new project, console application, pick 10B fall 2014. Okay, we'll click next. We're going to just do an empty project. I'll just uncheck this SDL thing. Just completely empty project. That's all we need right now. Click finish. Okay, I have no files here. Absolutely none. Okay, so let's add a source file. So the first thing we'll do is add a .cpp file. Call it source.cpp. That's fine. All right, now, number include, iostream, using namespace, std, and main. Turn 0, and we're going to do cout. And it's hello, and I was corrected on this morning. You need a comma, technically, to do the... Okay. Okay. And we're good to go. Okay, we got a hello world app working. All right, now, here's one style choice that I'm going to demand, both of myself and of your homework assignments, which is just something like the following. Here's that main page. And again, for your homework assignments, you don't have to do this exact style quite yet. But just make sure you have a commenting header that gives, well, actually, you know what? I will demand. Yeah, do it exactly the way I'm showing you right now. Okay, get in the practice of doing this. This is the main page, and it's going to be called Pick 10B Lecture Notes. The author is me, and the date, I'm just going to write fall quarter 2014. Okay? You should do something similar in your homework assignments. Do an at main page, homework assignment 1, author, write your name, date, fall quarter, and then you do a brief description. Okay, so this is the, I guess, main page for lecture notes for Pick 10B in fall 2014. I will post updated versions of the, let me go on a second line. I'll post updated versions of this file on CCLE as we add more content. Okay? Now, in particular, I can do things like I can make a section. You don't have to do this for your homework assignments, but just to show you, I am going to post this file on CCLE. So if you missed the course, or if you don't show up for the course one day or the lecture one day, and just looking at the source code is not enough, and just looking at the lecture slides posted is not enough, look at the video, and this is exactly going to be, should be pretty much the same file that I'm dynamically creating during the lectures. Okay, so section lecture 1. What did we do in lecture 1? I said hi? No. Let's see. Syllabus, difference, well, emphasis on C++ and C++ 11, Visual Studio 2012 Ultimate is what we are using. Oh, and I promised to show you an example of code that you're going to find on the internet, right, that's not going to compile. Okay, so let's do that right now. You guys remember a vector? Yeah, of course. Okay. Well, I mean, I hope of course. But okay, vector. A vector stores a collection of objects. It stores that collection of objects in memory in a very particular way. And we will, this quarter, go over precisely how the vector differs from other collections like a linked list and things like that. So I number include vector at the top. And now I get to write something like vector of int v. And now how would I add elements to v? Pushback, right? V dot push back. Say 43, v dot push back 3. Okay, wonderful. Now, here's the code that will, okay, now let me just make sure this compiles. Okay, that's fine. That works, compiles just fine. I didn't see out anything. I commented out that line below. So this is fine. Now, some of you are going to go on the internet, and you're going to see this code, or something like this. Call it v2. Now, how many think this code is going to compile? Well, obviously, if I'm phrasing it like this, it's OK. So this does not compile. But this code does not compile because of the reason you think it doesn't. Well, it does. But OK, so let me just explain the difference between C++ 11, which is a set of standards and rules that denote what are considered valid syntax. This is considered valid C++ 11 syntax. You will find it on the internet. People will champion its use. I love doing this. It works on your Mac. So you could do this on Xcode. It will compile. It is not valid code for Visual Studio 2012 Ultimate, which is what the PIC lab computers use to compile and run your homework assignments. So you cannot use this syntax. Okay? What this means is, just because you read it on the internet doesn't make it true. Now, that's a pretty good statement. Okay? So just remember, if you see a piece of syntax on the internet, always, always, always double check it on Visual Studio 2012 Ultimate. It will probably work on a Mac. If you run this code on Xcode, if you run the new C++ 11 stuff on Xcode, you might get things to compile because it's valid C++ 11 syntax. but it may not, it's not guaranteed to compile on Visual Studio 2012. I'm telling you this right now. You must double check for your homework assignment. If your code does not compile, it's an automatic 5 points off. It does not matter if it ran on your Xcode version or on your, and this is important, Visual Studio 2013. We do not have Visual Studio 2013. Okay? We're stuck with 12 for now, 2012. Okay? So that's the warning, is always double check. Especially if you're using a Mac, there are certain things which will compile on a Mac that will not compile on Visual Studio 2012. Okay, so that's illegal syntax. Get rid of that. Okay, now, here's another one. How do I print out all the elements in a vector? Say it louder. Loop through it. Okay, so what's an example? Like what? Give me an example of how. What particular syntax or keyword should I use? Because there is no loop, right? You loop through it. That's the idea. But there is no loop keyword. What is the name of the type of loop I should use? For loop. And this is important. What are the different types of loops in C++? Yeah. For, while, and do while. Okay? There are specific reasons when you use each one. Okay? When you're looping through a set of items which is fixed, there is a fixed starting point and a fixed ending point, and you know both of these things in advance, you use a for loop. When do you use a while loop? Well, just anything else. It's until, I mean, if something is modifying outside of that structure, you use a while loop. Okay? The for loop signifies I'm going to just do a fixed number of things in this region, and there's really nothing more complicated about it. Okay? If you have a loop which you can't predict how long it's going to go through the loop cycle, you're not going to use a for loop. You can write a for loop that works, that compiles and runs, but from a stylistic point of view, you do not use the for loop. Because the for loop signifies I have a definite starting point, a definite ending point. I'm going to do something a fixed number of times, and that fixed number of times is not going to change depending on what's in the thing. Okay? That's when you use the for loop. Everything else is a while loop. The for loop strongly indicates that you're doing something a fixed number of times. The while loop indicates everything else. Do while loops I'm actually a little more fond of than the creator of C++. The creator of C++ doesn't really like do while loops, he's been quoted as saying. So I don't have a problem with do while loops. Okay, so use those as much as you like if it makes sense. Okay, if you really do have to do some operations first and then loop around, then it makes sense to do it. Okay? But definitely the for loop is a little bit more. That one's a little more restrictive in where you use it. So how would I do this? So for, and now what would I write here? Int. I heard int and I heard size t. Okay, let me do the int I equals 0, I less than, what should I write here? v.size, I plus plus. Well, let's do pretty much. Okay, this code compiles, it runs. Okay, now, but did it compile? Hang on. It compiled and now it's not giving me the, hang on. Build clean. There we go. Now what is this? This is a warning, right? Warnings aren't a big deal, right? Well, it really depends on what your definition of big deal is, right? So if your entire purpose in life is to write a line of code that prints out 2 elements in a vector, precisely of this format right now, and that's all you're going to do in life, it's fine. You know, have a nice life. Okay. But if you want to write code that is cross-platform and exercises good artistic judgment, good style judgment, and demonstrates a more mastery of the language, then there are several things wrong with this line of code, with these lines of code. So first of all, what is the difference between an int? Now, how many have heard of a data type called size underscore t? Okay, how many have not heard of size underscore t? Yeah, it's usually safer to get a response when the majority of students are participating. Okay, so this is something that is not always taught in the intro level, like Pick 10A courses. I didn't even know about it until embarrassingly recently. But it is one of those cross-platform data types that is more important to utilize when you're working on more professional projects. And that is this idea of how many elements can a vector potentially have? Wow. Infinite is, I don't want to say no, but you have to specify what you mean. Here's a better response. You have to specify what you mean by infinite. Meaning, are you assuming a computer that, no, anyway, no, the answer is no. Okay, sorry. I mean, in theory, you can have a collection of an infinite number of objects, but that's more of a mathematical kind of conception. In terms of a computer, there's a limit, right? There's only so many bits on your machine. So there's a limit. There's a natural limit. Does anyone know what that limit is? Well, it's going to vary depending on your operating system. Okay? So there is no universally agreed upon maximum size for a vector. Okay? Which means that on one computer you might get this amount. On another computer, you might get twice as much or half as much. Okay? So when you write an int, for example, now how many bytes does an int take up? Do you guys know? 8. Is that a guarantee? No, it's not a guarantee. Right? Int can have, well, int is guaranteed to have at least as many as 4. Because car is 2 or 4? So int is guaranteed to have as many as short, and short is guaranteed to have at least as many as car. So there's no telling exactly how many bytes you have allocated. There's no telling exactly what data type is going to be sufficiently able to access every single element in the vector, which is why you use what's called size t. Okay, so size t is the cross-platform answer to the fundamental problem, which is, well, wait a minute. Isn't there a way not to name a data type, but to name like something like size t, which will, depending on this computer, get transformed into that data type, and on this computer, get transformed into the appropriate data type? That's what size t does. So size t basically looks at the particular operating system and determines what data type to convert it to so that it matches precisely the possible range of elements for a vector. Okay? So int is unpredictable. Int may give you exactly what you want. It may give you half as much as what you want. You can't predict it. Size t is the way to guarantee, no matter what computer you're on, that variable gets mapped correctly to be able to index all of the possible values stored in a vector. Okay, so again, if I write size t, my warning goes away. And I get the same results. Now, size t is essentially an unsigned int data type. It's an unsigned integer type. It usually gets mapped to literally unsigned int. But unsigned int will not necessarily cover all of the variables or all of the indices for a vector. Okay? Size t will get mapped to it. Most of the time it'll be unsigned int, but on those rare occasions where it's something else, the size t indicates map it to wherever it needs to go. Okay? Now, there is a subtle efficiency part to this code as well. Does anyone know what the sort of efficiency gap is? Exactly. So, excuse me, what happens is, right, every time the loop runs, it checks the condition and then runs the code. Checks the condition, runs the code. Well, every time it checks the condition, what function is it calling? v.size. Is v.size changing at all? No, that's why we're using a for loop, because we're doing a fixed set of things, and there's no intention of having to do anything else. So we should not include it in the test condition. Again, this course is not purely about optimizing or getting the most out of your code. But it is about being aware of a little more refined set of logic about how the code is actually being interpreted. Okay? So when this code runs, it's going to go I is 0, that's less than the size, print that out. Then it's going to go again, increment to 1, check it, 1 is less than 2, so it runs again. And then it checks, but then it keeps calling v.size each time. So if you took 10a with me, I probably mentioned this new syntax, which is the following. This is something that's kind of neat. Guys, remember, if you want to define a second variable, comma, n equals v.size. Okay, check that out. Let me put some space in here as well to just emphasize. Okay, so this is the initial test or initial code. This is our test condition, and this is our increment condition. Okay, so now what happens is the v.size function gets called once, initially. Then the test condition is just I less than n. Okay? In addition, you get an added bonus by this as well. Because, now some of you may have been tempted to write size t n equals v.size and leave this out of the loop. But then the variable n has meaning outside the loop. And you probably don't want the variable n sticking around after that loop is run. This formulation of it makes variables I and n local just to that loop. As soon as the loop is done running, the variables I and n have no meaning. In other words, if I try and do something here, and I try to see out n, this is my 2-minute warning. Sounds like this. Yeah, that clock at the bottom there is wrong. It's 12:48. Okay, so if I try to print out n is undefined. Okay? So again, this is, if you're going to print out the elements in a vector, you can do it the incredibly naive way, which will work on this computer for a very small size list of vectors. You can do it the slightly more cross-platform way, which is using size t and saying, aha, I am aware of the fact that different computers implement these things slightly differently. And I know size t will take that into consideration. And then there's the final step of, aha, I'm calling v.size over and over and over again when there's no need to. I would much rather access a value than call a function each time. And so that's why we do that syntax. Then we also get the added bonus of knowing variables I and n are localized to just that operation. And we can reuse them further below. Okay? So that is the initial lesson. One last thing. So n is not defined outside of the loop. Again, I'll post this code. In particular, every for loop, if else, etc., must have comments describing it. Okay? Every function needs to have the comments. The structure is in your book. It follows the same structure as your book. But I'm adding to it. Every for loop needs to have comments. Every if statement needs to have comments. Every branch of those have to have comments. You have to describe in words what the code is supposed to do in such a way that someone who maybe even doesn't even know C++ can still understand it. Okay, so while you're doing the first homework assignment, I'm going to be lenient on the commenting initially. But by the second homework assignment, yes, you must incorporate all of these standard commenting styles, and also for variable names as well. I haven't done a good job of it because my variable names don't signify anything, but n should probably have been something like vector size or something like that. Okay, so that's less than ideal for variable names, but in terms of commenting, in terms of style, just to give you an idea of, yes, I am going to emphasize style in Pick 10b. Okay, so on Monday we're going to start off with a review of classes, and then I'm going to and member functions, public, private, and then hopefully go into operator overloading right away.